This videotape deals with addition and subtraction of fractions. Most of you remember the rules for adding and subtraction arithmetic fractions. If you want to add two fractions with the same denominator, assume of course the denominator is not 0 because we can't divide by 0, but if you want to add two fractions having the same denominator, you add the numerators and put them over the common denominator here. So a over c plus b over c is a plus b over c. You add the numerators and put them over the denominator. Or if you want to subtract two fractions having the same denominator, you subtract the numerators and put them over the same denominator. Okay, you do not change the denominator. Okay, I realize that when you multiply fractions, if you wanted to multiply a over c times b over c, this would be, well, you multiply the tops, giving you ab, and divide by the product of the denominators, giving you c squared. Well, that's for multiplication. You multiply the tops and divide by the product of the bottoms. Okay, but if you're adding or subtracting, you leave the denominator alone. You add the tops, you subtract the tops, you put them over the same denominator. You do not change the denominator. This is not multiplication. The denominator and the answer is going to be the same as the denominator in the original part of the problem. Okay, now this can be used for more than two fractions. Let's try a problem. 2/9 take away 7/9 plus 8/9. Okay. We combine the numerators. We get 2 minus 7 plus 8 over 9. 2 minus 7. Okay, that gives us minus 5 plus 8. That's plus 3 over 9. Now, this particular fraction is not in lowest terms. We know that we can, they have a factor in common, the numerator and the denominator. The factor, of course, is 3. We can rewrite the numerator as 3 times 1, and the denominator as 3 times 3. And we see here the 3's will cancel. Okay, this is according to the fundamental principle of fractions. The final answer here will be 1/3. Okay, I'm going to go over to the sideboard just to review the fundamental principle of fractions for you. If you have a fraction, a over k divided by b over k, you can divide numerator and denominator by k, and this is equal to a over b. Working the other way, if you have a fraction a over b, if you multiply the top and the bottom by the same non-zero number, k, okay, you get an equivalent fraction. Okay, so going in this direction to reduce fractions, you can cancel the k's. Okay, working the other way, you can multiply the top and the bottom of a fraction by the same non-zero number and get an equivalent fraction. Okay, let's go back to the front board. And what we did over here, okay, we had 3/9. That was 3 times 1 over 3 times 3. We divided top and bottom by the same non-zero number 3. The 3's canceled, giving us a final answer of 1/3. Okay, now that's fine for arithmetic fractions. Now what about fractions that involve variables? Okay, algebraic fractions. Let's try a problem now. 9 over 5x plus 7 over 5x minus 6 over 5x. Okay, these are handled in the same way. They have the same denominator. As long as fractions have the same denominator, you can combine the numerators and put them over the same denominator. So here we would get 9 plus 7 minus 6 over 5x. 9 plus 7, that's 16 minus 6, that's 10 over 5x. Once again, this fraction is not in lowest form. Lowest terms here, 10 is really 5 times 2. So this is 5 times 2 divided by 5 times x. Okay, we can divide the numerator and denominator by 5 or cancel the 5s to get a final answer of 2 over x. Okay, now all of our rules for adding and subtracting fractions are based upon the fractions having the same denominator. Now, what if you want to add or subtract two fractions? They don't have the same denominator. What we're going to have to do in such a case is to find fractions that are equivalent to the ones we want to add and subtract, all having the same denominator, and then we'll proceed as before. And we'll be using the fundamental principle again to find these equivalent fractions. Let's look at a specific problem. 3/8, let me put it over here. 3/8 minus 5/6 plus 1/10. Okay, we'll start with arithmetic fractions and work our way up to algebraic fractions. Okay, here we'd like to add, combine these fractions, and they don't have the same denominator. Okay, so what we're going to do first is to transform each of these fractions into an equivalent fraction. And each of these equivalent fractions should have the same denominator. Okay, now what's going to be the denominator? Okay, we are looking for the smallest number that 8, 6, and 10 go into. Okay, that 8, 6, and 10 divide evenly into. Okay, let's look and see what we can do. Now, you can always, in a pinch, use the product of the denominators. 8 times 6, 48 times 10, 480, the product of the denominators. 8, 6, and 10 all go evenly into 480. Okay, but generally you can do a lot better. If you use a denominator that is too large, okay, say the product of the denominators, it's not catastrophic. You can get the correct answer, except the answer that you'll get to the problem won't be in lowest terms, and in more complicated problems, the difficulties will get a little worse, but you will get the right answer. However, it's usually advantageous to try to find the lowest common denominator, the smallest number, so that 8, 6, and 10, okay, all divided evenly. Let's see what we can do. Okay, now 480 is too large. It turns out in this particular problem that for 8, 6, and 10, the smallest number that we could use happens to be 120. Okay, let's see if we can verify that. Let me show you a way of finding the lowest common denominator. Method for finding the LCD, lowest common denominator. Okay, factor each of the denominators completely. Factor each of the denominators completely. Okay? If you have an integer, I would want you to write down the prime factorization. Okay? Write integers as the product of prime numbers. Write integers as the products of primes. Okay? Factor each of the denominators completely, then take each of the different factors that occur. Take each of the different factors the largest number of times. The largest number of times it appears in any one denominator. Okay. Okay, so we're going to factor each of the denominators completely. Integers will be written as the product of primes. We'll take each of the different factors the largest number of times it appears in any one denominator. Okay, let's try this procedure okay, on this problem. Now, in this particular problem, the denominators we had denominators 8, 6, and 10. Okay? So we go over here, we write 8, 6, and 10. Each of these integers is going to be written as a product of primes. Okay, 8 is 2 times 2 times 2. Okay, you can see it's an even number. You divide 8 by 2, you get 4. Divide 4 by 2, you get 2. And you do it that way. In other words, you could start with 2 times 4, and then 4 is not prime. You can make that 2 times 2. Okay, here. 6 divided by 2 gives you 3, and 2 and 3 are both primes. 10 divided by 2 gives you 5. 2 and 5 are both primes. Okay, now to form the lowest common denominator, okay, what we do is we take each of the different factors. Let's see, what are the different factors? We have 2's, 3's, and 5's. We take each of the different factors, the largest number of times it appears in any one denominator. Okay, we know that we're going to need 2's, 3's, and 5's in our answer. Now we say, how many 2's? Here there's 1 2, here there's 1 2, here there are 3 2's. We will need 3 2's. We take it the largest number of times it appears. There's 1 2, 1 2, 3 2's. We will need 3 2's to cover us on the 8. Then we look at 3. There are no 3's, 1 3, no 3's. Therefore, 3 occurs once in the LCD. And then we look at 5. There are no 5's, no 5's, 1 5. The largest number of times 5 occurs, of course, is just 1. So we get 2 times 2 times 2 times 3 times 5. This gives us 2 times 2, 4 times 2, 8 times 3, 24 times 5, 120 for the lowest common denominator. And as I mentioned before, nothing catastrophic would happen if you used 8 times 6 times 10, 480, but it usually is a lot better to use the smallest number, okay, such that 8, 6, and 10 are all divisors of that number. Okay, now we've decided on 120. Okay, what we want to do is build fractions. We would like to transform each of these fractions into an equivalent fraction having a denominator of 120. Okay, and the way we're going to do this is to use the fundamental principle. That is, we know it is perfectly legitimate to multiply the top and the bottom, okay, of a fraction by a non-zero number. We'll get an equivalent fraction. Right, for example, if I multiply the top and the bottom here by 2 instead of 3/8, I get 6 over 16, which is the same as 3/8. Okay, so the question is, what do we multiply top and bottom by in each case to get the 120? Now, first of all, we know that we will be able to find the number to multiply each of these numbers by to get 120 because each of these numbers are factors of 120. 8 divides 120 without a remainder, so does 6, so does 10. That's why 120 was picked. It was the smallest number such that 8, 6, and 10 were all factors of it. Okay, let's see. Now, a nice way of doing this, of course, you can always use long division to figure out how many times 8 goes into 120 or 6 goes into 120, whatever. Another way of doing it would be to go over here and to see, well, 8 is 222, and 120 is 22235. So we can see that what we're missing is the 15, 3 times 5. Whereas, how many times does 8 go into 120? How many times does 222 go into 22235? Okay, obviously 15 times. This is 120 is really 8 times 15. In this particular case, I will multiply top and the bottom, this fraction, by 15. 8 times 15, of course, gives you the 120. 3 times 15, 45. Okay, this procedure is known as building fractions. Okay, we're used to reducing fractions, starting with something like 45 over 120, reducing it to lowest terms and getting 3/8. Okay, what we're trying now to do is to build fractions. All of these fractions are supposed to be built up till we get equivalent fractions, all having the same denominator. Because to add fractions, we have to have the same denominator. Okay, 6 into 120. Okay, you can work out the same procedure with the primes, or you may just happen to know that 6 times 20 is 120. Okay, so we multiply top and bottom by 20. to give us 100 over 120. 6 times 20 gives us 120. 5 times 20, that's 100. 100 over 120 is the same as 5 over 6. Okay, now, 10 into 120. Okay, you tell yourself, what do you have to multiply 10 by to get 120? Okay, well, I have to multiply 10 by 12 to get 120. Well, whatever you do to the bottom, you've also got to do to the top. That's what the fundamental principle is telling you. You multiply the bottom by some number. You must also multiply the top by that number. Otherwise, you won't get an equivalent fraction. And this gives us 12 over 120. In a sense, you can think of the fundamental principle as really multiplying by 1. Really, this is the same as 3/8 times 15 over 15. 15 over 15, of course, is 1. And we all know that 1 is the multiplicative identity. You can always multiply a number by 1 and not change its value. Okay, so that's all we're really doing here. In each case, we are multiplying by 1, but in a very clever form. Okay, so that our goal is that we have the same denominator in each of these fractions. Now we're ready to do the problem. Okay. 3/8 minus 5/6 plus 1/10. Well, 3/8 is the same as 45 over 120. Take away 5/6, but 5/6 is 100 over 120. And add 1/10, but 1/10 is 12 over 120. Okay, this reduces to the kind of problem that we handled earlier in this videotape. Okay, same denominator. We want to add and subtract these fractions, so we combine the numerators and put them over the same denominator, 120. Okay, and this gives us 45, take away 100, that's minus 55, plus 12, that's minus 43 over 120, and that's already in lowest terms. 43 is a prime. Okay, let's try another problem. Now we're going to add and subtract fractions that don't have the same denominator and which involve variables. Okay, so far we're sticking with arithmetic fractions. Now algebraic fractions. Okay, let's try 3 over 4 x squared y plus 5 over 6 xy. Okay, now your procedures are going to be exactly the same. In order to add these fractions, you're going to have to transform each of these fractions into an equivalent fraction having the same denominator. Okay, the question is, what is that denominator? We have to find the lowest common denominator in this problem. Okay, now we can proceed as we did before. Okay, if you happen to just see it, fine. But if not, we can proceed as before. We'll factor completely each denominator. 4x squared y, 6xy are the two denominators. We factor completely. 4 is written as 2 times 2, the product of primes. X squared y is x times y. And then 6 is 2 times 3 times x here times y. Okay, now, the lowest common denominator, we're going to take each of the factors, the largest number of times it appears in any one denominator. Let's see. We have 4 factors involved: 2's, 3's, x's, and y's. Okay, let's start with 2. Here is 1 2. Here are 2 2's. Therefore, 2 must be taken twice. Here it's once. Here it occurs twice. We must take it the larger number of times. Let's look at 3. Here it's once. Here it does not appear at all. 0 3's, 1 3. We write down 1 3. Now x. 1x, 2 x's. We need 2 x's. And y occurs once here, so once will be sufficient. This gives us 4 times 3, 12, x squared y as the lowest common denominator. Now, after a while, you'll sort of get good at this, and you'll be able to figure out the lowest common denominator without all of this, work. Whereas we want the smallest number, so that 4x squared y and 6xy are both factors, okay? And the smallest number is 12x squared y. Okay, we would like to write these as two fractions, each having denominator 12x squared y. Okay, and we look at 4x squared y, and we say, what would we have to multiply 4x squared by to get 12x squared y? Okay, now, to go from 4x squared y to 12x squared y, we'd have to multiply by 3. Well, if you're going to multiply the denominator here by 3, then you're also going to have to multiply the numerator by 3. That's the fundamental principle. It's okay to multiply the top and the bottom of any fraction by the same non-zero number. But if you do it to the bottom, you've got to do it to the top as well. So since we want to make the denominator 12x squared y, and we have to multiply the denominator here by 3 to get it, we also have to multiply the numerator by 3. Now let's look at 6xy. What will we have to do to 6xy to get 12x squared y? Well, to go from 6 to 12, we'd have to multiply by 2. To go from x to x squared, we need another x. We already have the y. Whereas we'd have to multiply by 2x. This would give us 12x squared y, which is what we want. Okay, if you're going to multiply the bottom by 2x, you have to also multiply the top by 2x. All right, so what we have here is 3 times 3, or 9, over 12x squared y, plus 5 times 2x, 10x over 12x squared y. And now we're ready to add the fractions. And our final answer to this problem, we're adding two fractions that have the same denominator. So we add the numerators, and we combine over the same denominator. This is the answer. You can't reduce it any further. Okay? Don't try to take things out of the 9 and the 12, okay, or factor out these x's. The fundamental principle, let me remind you, says that if you have a times k over b times k, it's perfectly okay to divide top and bottom by k, assuming, b and k here are not 0, and get a over b. That's legitimate. It does not say that a plus k over b plus k, okay, is a over b. Okay, 9 is not a factor of the numerator. This is not 9 times 10x over 12x squared y. If it was 9 times 10x over 12x squared y, 9 would be a factor of the numerator. We could factor things out. The 3 would, you could divide the 9 by 3, the 12 by 3. That's an altogether different problem. Okay, this plus sign means we're adding here two terms over the same denominator. Okay, this is not a factor. 10x is not a factor. X is not a factor of the numerator. You can't cancel out the x's. Okay, if you have factors here, if you have a times k over b times k, then you can cancel the k's and get a over b. But it does not work for addition. Okay, let's try another problem. X plus 3 over x. Okay, we would like to add these fractions. And x really, of course, is x over 1. If it makes you feel a little bit better, you see it more as a problem in adding fractions. Okay, x plus 3 over x. Your first step is to write it as x over 1 plus 3 over x. Now, the lowest common denominator in this particular case is just a product of the denominators. Okay, just 1 times x, or x. Okay, we'd like to turn both of these fractions into equivalent fractions having the denominator x. Well, the 3 over x is already okay. It already has the denominator x. Let's look at x over 1. In order to get the denominator of x, we would have to multiply this denominator 1 by x. Therefore, we also have to multiply the numerator by x. Okay? If we'd like to have a denominator of x, we have a denominator of 1, we would have to multiply by x. We have to therefore also multiply the numerator by x. This gives us x squared over x plus 3 over x. Two fractions, same denominator. We add the numerators and put over the same denominator. X squared plus 3 over x. And this is as far as you go in this problem. You cannot factor out x's here. You cannot divide top and bottom by x. Okay, this is not the same problem as 3x squared over x, or x squared times 3. This is x squared plus 3 over x. 3 is not a factor of the numerator. If it was x squared times 3 over x, or 3x squared over x, then you could reduce it to 3x. In other words, divide numerator and denominator by x. But that's x squared times 3. This is x squared plus 3. This is already in the lowest terms. Okay, let's try some more problems. 5a plus 3 over 2a, take away 4a plus 3 over 2a. We'd like to subtract these two fractions. Now, they already have the same denominator, so you don't have to worry about that. But even when fractions have the same denominator, you still have to be careful. Okay, what we're supposed to do is subtract the numerators and put them over the same denominator. Okay, 5a plus 3, take away 4a plus 3. You must put in these parentheses. Okay, we don't want to make any mistakes. We're subtracting 4a plus 3. Okay, parentheses are sort of implied here. Okay, if you just take away, if you just write minus 4a plus 3, you're going to think of it just like that, minus 4a plus 3. But really, this is a minus 1 to be distributed through the parentheses, giving you minus 4a minus 3. Okay, so when the fraction you're subtracting here has, say, a binomial in the numerator, more than one term in the numerator, okay, you must put parentheses around it to keep everything clear. Okay, now we're going to combine like terms in the numerator. We have 5a plus 3 minus 4a minus 3 over 2a. Okay, the 3 minus 3, that gives you 0. 5a minus 4a gives you 1a, or just a. And the denominator is 2a. And of course, you can cancel the a's, getting a final answer of 1/2. Okay, the 3's minus 3 gives you 0. 5a minus 4a is a, or 1a. The denominator is 2a. You can divide numerator and denominator by a, or cancel the a's to get 1/2. Okay, I'm now going to put two problems on the board. It would be a good idea for you to try these problems on your own. You can shut off the videotape machine, and after you've done the problems, turn the machine on and see the solution. Take away y minus 11 over 4. And the second one is 5 over 6 x squared y cubed minus 3 over 10 x cubed y squared. So shut the machine off, try them, and then come back to me. Okay, now for the solutions. In the first problem, these two fractions have the same denominator, so we will subtract the numerators and put them over the same denominator. Of course, we will be careful to put parentheses around the y minus 11. These parentheses are sort of optional, but when you subtract, then you must write down the parentheses. Okay, this gives us 2y minus 7. Now, distributing the minus 1, there's really a minus 1 here. Through the parentheses, you get minus 1 times y minus y. Minus 1 times minus 11, that's plus 11, over 4. 2y minus y gives you y. Minus 7 plus 11, that's plus 4 over 4. Y plus 4 over 4. This is the answer to the problem. You cannot cancel the 4's. Okay, if it was y times 4 over 4, then 4 would be a factor in the numerator. You could divide numerator and denominator by 4 and get an answer of y. Okay? Here you cannot cancel the 4's and say get y plus 1. 4 is not a factor in the numerator. This is the final answer. Okay, now on this problem, we want to subtract the fractions, but we notice that they have different denominators. So first we'll have to go over here and find the lowest common denominator. We will look at 6x squared y cubed and 10x cubed y squared. We will factor them completely. 6, of course, is 2 times 3, written as product of primes. X squared, x times x, y cubed, y times y times y. Now 10, that's 2 times 5, x cubed, x times x times x, y squared, y times y. Now we form the lowest common denominator. And we see we have a factor 2. 2 occurs once here and once here, so it occurs once in the LCD. Okay, then we have a factor of 3. Once here, 0 times here, so we have to put it in the 1 time. 5. There are no 5's. Here is 1 5, so it has to go in once. It goes in the largest number of times it appears. X. X occurs twice here, occurs 3 times here, so we'll need all 3 of them. Y occurs 3 times here, twice here. We'll need all 3. Okay, so our LCD is 2 times 3, 6 times 5, 30, x cubed, y cubed. All right, what we want to do is to get equivalent fractions here, each having the denominator 30, x cubed, y cubed. That's our goal. Okay, now we say, what would we have to do, what would we have to multiply this denominator by to get 30x cubed, y cubed? Okay, whatever we multiply the bottom by, we'll also have to multiply the top by that same quantity. Now, to go from 6x squared y cubed to 30x cubed y cubed. Well, to go from 6 to 30, we'd have to multiply by 5. To go from x squared to x cubed, you'd have to multiply by x. Y cubed to y cubed, we're already okay. That'd just be multiplication by 1, so we don't need that in there. So if you multiply the denominator here by 5x, you would get 30x cubed y cubed, which is what you want. So you have to multiply the numerator also by 5x. Then we look at this denominator, 10x cubed y squared. And we want to figure out what we have to multiply that denominator by to get the 30x cubed y cubed. All right. To go from 10 to 30, you'd have to multiply by 3. To go from x cubed to x cubed, you'd multiply by 1, so we can leave that out. To go from y squared to y cubed, you'd have to multiply by y. 10x cubed y squared times 3y will give you 30x cubed y cubed, which is what we have there. So we will also multiply the top by 3y as well. Okay, let's see what we have. We have 25x over 30x cubed y cubed minus now 9y over 30x cubed y cubed. And your final answer, if you want to subtract two fractions, same denominator, you just subtract the numerators and put them over the common denominator. So your final answer is 25x minus 9y. Subtract the numerators and put them over the same denominator. And no further simplification is possible here. And that's the answer. Okay, this is also the end of the videotape. If you have any questions, you can consult with a tutor in the math lab or view the videotape again.